Good morning, Year 11s. I hope you're all doing really well. Starting with geometric proof, I wanted to introduce the concept by doing this circle theorem question. In this question, which is on the PowerPoint, we have to prove that y equals 2x. Now, in order to prove that y, which is the angle here, is the same as the angle 2x, we have to do some geometric manipulations here. Now, whenever you see a question to do with circle theorems, my advice would be you write down anything on the diagram that you know of. So I'll give you a moment just to look at the diagram. Is there anything that you can see there that we can put on the diagram? Now, I'm hoping that by now you've seen that you've got a tangent AQ and a tangent AP, and the tangent is meeting the radius. Now, the theorem is that tangent meets the radius at 90 degrees. So we put that on. This is 90 degrees and this is 90 degrees. And if I just make an inclination for the angle here, we can see that we've got a quadrilateral ABOD, and angles in this quadrilateral would add up to 360. So we could use that at some point in order to get to our answer. We don't know anything which will lead there, but we're just starting it off. Anything else we can see in there? You can see that this triangle, BOC, is an isosceles triangle because you've got two radii, they're equal in length, and therefore the angles they would make would also be the same. There's going to be these two angles here. Now, in order to find this angle, we can see that we've got a straight line, so all these three angles add up to 180. So we have at the moment got 90 and 2x, so this angle here would be 180 take away 90 plus 2x, which gives us the angle 180 take away 90, take away 2x. This minus affects all of those values, make them all negative. So the angle we're left with is 90 minus 2x, which is this one here. Since it's an isosceles triangle, this angle would also be the same. What we can do is we can find what this angle is inside the triangle, which is the final angle here. Angles in a triangle add up to 180. We already know two of those angles, so if I do it on the side, 180 take away 90 minus 2x plus 90 minus 2x is 180 take away 4x. If I expand the brackets, everything in the bracket will change its sign. This 180, this negative 180 cancels out. We're left with 4x. So this angle is 4x. Using the same principle we did before with two radii make an isosceles triangle, we can see if this angle is an x, well, this is a radii, and that's a radii, then the radii are all the same, but the angles they make are different in each of the triangles. So this is x, which means this angle here would also be x. We leave to find this angle here now. That's 180 take away 2x, because these are the two other angles in there. Now, we can see here we've got angles around a point, and they must add up to 360. So the next thing we can do is we can try and find out what this angle here would be. (360) minus 4x plus 180 minus 2x. And that's 360 take away 180 plus 2x, which is 180 take away 2x. So that's this angle here. Now if I have a quick look, just checking another circle theorem, angle at the center is twice the angle at the circumference. The angle at the circumference is 90 take away x altogether. If I add 90 take away 2x and an x, it gives me 90 minus x, which is this angle here altogether. And this is 180 minus 2x. So we can see we've done all the steps correctly because whatever this angle is here, we've got double here. And now we've got lastly something to prove. We've got to prove that angle y is equal to 2x. So we add up all the angles that are in this quadrilateral, and we are using geometric knowledge that angles in a quadrilateral add up to 360. So I'm going to move this slightly down so you guys can all see. So I start with y, just going to set my camera, plus 90 plus 90 plus 180 minus 2x equals 360. +90 plus 180 is 360. Y take away 2x plus 360 equals 360. You can probably see where this is going now. If we take these two terms to the other side, we're left with y equals 2x plus 360 minus 360. They cancel out. And we've got our answer, y equals 2x, which we have proved using all the knowledge that we had to do with geometry. Now, in a question like this, depending on how many marks there are and depending on whether the question says give reasons for each stage of the working, you may have to write reasons like angle OCD is equal to angle ODC because two radii make an isosceles triangle. Or you'll have to say angle ODA is 90 degrees because tangent meets the radii at 90. Or you may have to say angles around the point is 360, which is why this angle is this. So depending on the question, you can go into that much detail, but this is the overview of a geometric proof. I will post a picture of this as well on the Google Classroom, so hopefully you guys can get a bit of benefit from that if you haven't managed to watch the whole video for whatever reason. If you need any more help, Year 11s, let me know. Take care and stay safe.